So question number 1. The stem lengths of a sample of 120 tulips are recorded in a grouped frequency table. A histogram is drawn to represent these data. The area of the bar representing 40 to 42 class is 16.5. Okay, 16.5 centimeters squared. Okay. Calculate the exact area of the bar representing 42 to 45. Okay, so basically we know that frequency or the area of the bar represents the frequency, or you can say proportional to frequency. So area is proportional to frequency. Okay, so A1, A2, for example, you could write F1, F2. Okay, so we were looking for A, let's say for example for the second group, you could also write it like this. Okay, so we have this area is 16.5. No, actually we're looking for that area 2, sorry, we are looking for this. Okay, so area 2 is unknown, area 1 is 16.5, and then frequency 2 is 18 and 12. Okay, so area 2 would just simply be 18 over 12 times by 16.5. So 18 times by 16.5 divided by 12, that is 24.75. Exact area, we can write 24.75 or 99 by 4. Or 24.75. 24.75 centimeters squared. Right, okay, so I'll just simply copy this. I'm sorry. Let's keep it as it is. Okay, the height of the tallest bar in the histogram is 10 centimeters. Tallest height represents the frequency density. Okay, not directly frequency because the class width could also be changing. So height represents the frequency density in a histogram. Okay, so we are going to find out which one it is. Okay, so we don't have that, right? Okay, so first off we need to figure out which has the highest frequency density. So let's find out. So 12 divided by 2, that is 6. Let's say this is a frequency density column. So this is 6. Then we have 18 divided by 3. 45 divided by 3. Okay. Then we have 23 divided by 5. 4.6. Then we have 35 divided by 5. 7. Then we have 24 divided by 3, again, 8. And 8 divided by 2, 4. So highest is going to be this one. Okay, this class. Second highest is going to be the 7. Okay, so we can use the proportionality over here also, that height 2, height 1 is equal to frequency density 2, frequency density 1. So height, we are looking for this. Frequency density of that is 7, 8 times by 10. So 70 divided by 8, that is 8.75. Okay. Q1 for these data is 45 centimeter. That is the lower quartile. Use linear interpolation to find an estimate for median, the interquartile range. So basically we need the median and the upper quartile. Okay, so first off, what we're going to do is we need to figure out cumulative frequency over here. So this is 12, then we have 12 plus 18, 30, 30 plus 23, 53. This is cumulative frequency. 53 plus 35, we end up with 88, plus 24, that is 112, and then 112 plus 8, 120. Okay, so for the median, we have 50% of 120, which is 60. So we need to look for where 60 is. So 60 is going to be in this region over here, this class over here, right? And while we're at it, let's find out the class for the upper quartile also, 90. So that's going to be right in this class. Okay, all right. So what we're going to need is we'll copy this information so we can, make linear interpolation. So we just need basically, sorry, these three over here. Okay, right. Right. So that was 60. Okay. So for the Q2, when we make a line for this, we are starting with 50, ending at 55. Somewhere over here is Q2. The frequency 53 and 88, 60 is the median. Okay, so what we're going to write is Q2 minus 50 divided by 60 minus 53 equals to 55 minus 50 divided by 88 minus 53. Okay, so let's simplify this a little bit. So we have 55 minus 50 divided by 88 minus 53 times by 60 minus 53, and then finally we're adding 50 onto it, so that is 51. Q2 is 51. Now we need the Q3 for the interquartile range. We will do the same process. So 55, somewhere over here is Q3, 58, 88, 90, 112. Now what I'm going to do is switch up the linear interpolation formula a little bit just to show you that it means the same thing. So Q3 minus 55 divided by, let's stay on the top this time, 58 minus 55 divided by 90 minus 88 divided by 112 minus 88. So mathematically it will be the same thing. If you in the denominator for example this one, you write 90 minus 88, it would be mathematically the same thing. Okay, now let's put this into the calculator. So we have 90 minus 88, 2 or 112 minus 88 times by 3 plus 55. That is 55.25. Okay, now the interquartile range is going to be equal to upper quartile minus the lower quartile. So 55.25 minus 51. 4.25. Okay, all right. So this was the part C. One measure of skewness is given by Q3 minus 2Q2 plus Q1 divided by Q3 minus Q1. Okay, by calculating this measure, describe the skewness of the data. All right, so let's plug in the values. 51 was the Q1. Oh, no, sorry, this is Q2. Q1 they gave us that, and Q3 we calculated 55.25. Okay, so when we calculate this, we have 55.25 minus 2 times by 51 plus 45 divided by interquartile range, that came out to be 4.25. Okay. So 55.25 minus 2 times by 51 plus 45 divided by 4.25. That is negative 0.41. Okay, so what does negative skewness over here mean? So the value is close to 0, so it's not that much of a problem. So we'll figure out how to write this, however. But what does the word negative skewness mean? Negative skewness means that it has a little bit of tail to the left of the mean. Okay, so this is what the negative skewness means. Okay, so we will say that skewness coefficient is close to 0 but negative, indicating slightly longer tail left of me. Okay, no, sorry, that was part D. Sorry, that was part D. Okay, all right, moving on to question number 2. The production cost in million of a film and total ticket sales T million earned by the film are recorded for a sample of 40 films. Some summary statistics are given below. Find the value of STT and find the value of SCT. Okay, so what I'll just do is I'll just simply screenshot this and paste it below so I don't have to scroll up and down again. Oh, sorry. So okay, we have to find out STT and SCT. Okay. So for STT, what we will have to do, sigma x squared minus sigma x whole squared divided by n. So sigma x squared, no, sorry, my bad, this was t, sorry, this was t, my bad, old habits, t and t. So we have t squared, 82873 minus sigma t 1361 whole square divided by, how many were the 40? Okay, so we have 82873 minus 1361 whole square divided by 4. No, sorry, divided by 40. So that is 36564.975. So in the answer, we will write it as 36564. That's let's call it 5. Oh no, we need the exact value. Okay, no, exact value is this. Exact value is that. Okay. Now the SCT. So that will be CT divided. No. minus sigma c sigma t divided by, this is sigma, okay, ct. This was squared. So we have over here 83634 minus sigma c is 1634 times by 1361 divided by 40. Okay, so 83634 minus 1634 times by 1361 divided by 40. We get 28037.15. Right, okay. Calculate the value of the product moment correlation coefficient for the data. Okay, so for the product moment correlation, we will need SCT divided by SC times by ST. Okay, so SCT we have calculated, STT we have calculated, we need the SCC. Oh, they have already given us that. Okay, we don't have to calculate anything else. Okay, just the square roots. So SCT 28037.15 divided by the square root of STT 36564.975 times by the 28732.15. Okay, all right, now let's plug this into this. So 28037.15 divided by square root of 36564.975 times by 28732.1. We get 0.865. Right, okay. Give an interpretation for your answer to part B. Okay. So first off, it's positive and it's close to 1. PMCC indicates a fairly strong relationship between cost, no, sorry, ticket sales and production cost. Positive relationship, production cost, and ticket sales. Okay, all right. Show that the equation of the linear regression line of T on C can be written as like this. Okay, so first off, we need to find out the A plus BX. Actually, this is the ticket sales. Wait, sorry. No, okay. So that's T. This is T, this is the C. Right, okay. So over here, we know that B is going to be equal to SCT divided by SCC. So SCT, we calculated it to be 2803715 divided by SCC, they gave us SCC 28732.1. Wait, sorry, 287321. Okay, so we have 28037.15 divided by 28732.1. we have 0.97581276669. Just for keeping things a little bit more accurate over here to avoid any problems with the rounding errors. Okay, now for the A, we will have to do the T bar minus B C bar. So T bar is the sigma T over 40 minus B times by sigma C over 40. So sigma T was, oh, we actually, I wrote it over here, 1361 and 1634. Right, okay, divided by 40, divided by 40. And B remains the same. So 1361 divided by 1361 divided by 40 minus answer times by 1634 divided by 40. So A comes out to be minus 5.8369151528. Okay, now since we have to show, yeah, up to 3 significant figures, we just have to show that. Okay, so up to 3 significant figures, T can be written as minus 5.84. B was also negative, no, sorry, positive, plus 0.976 C. Okay, all right. Find the expected total sales for a film with a production cost of 90 millions. Okay. So total cost when cost is 90 million. So 5.84 plus 0.976, 90. So minus 5.84 plus 976 times by 90. 82. 82 million. Okay. Using the regression line in D, find the range of values of the production cost of a film for which the total sales are less than 80% of its production cost. So we have to treat it like an inequality break. Find the range of values of the production cost of a film. Production cost for which the total ticket sales are less than 80% of its production cost. Okay, alright, so T less than 0.80. See, T itself is governed by that minus 5.84 plus 0.976 C less than 0.8 C. Okay, so we take 5.84 on the other side and 0.8 on this side minus 0.8 C less than 5.84. So 0.976 minus 0.8, that is going to be 0.176 less than 5.84. So production cost is less than 33.18. Wait, now let's see what did they ask again. Find the range of values for the production cost of a film for which the total ticket sales are less than 80% of its production cost. Yeah, so that's about it. So 33.18. Production cost C will be less than 33.18 millions. Okay, All right, so we can, stick to it like that. Okay, right. Okay, so moving on. Question number 3. Morgan is investigating the body length b centimeters of squirrels. A random sample of 8 squirrels is taken and data for each squirrel is coded using x is equal to b minus 21 over 2. Right, so basically we can rearrange it like b is equal to 2x plus 21. Okay, the results for the coded data are shown below. Find the mean of b. Okay, so for the mean of b, we will use this equation that I've just written, 2x plus 21. So mean of b is actually related to the mean of x by simply this formula. So that would be just simply 2 minus 1.2 divided by, how many squirrels were there? 8 squirrels plus 21. So 2 times by minus 1.2 divided by 8 plus 21. 20.7. Okay, find the standard deviation of b. That is also straightforward. If I have this equation, b is equal to 2x plus 21. So variance of b will be equal to 2 squared variance of x, or since we're looking for standard deviation, sigma b would be just simply 2 times by sigma of x, not 6 sigma of x. So basically we need to find out the standard deviation of x. So sigma of x, starting with that, x squared minus sigma x over n whole square over n. So sigma x squared, they have given 5.1 divided by 8, right? Okay, minus the mean we calculated, that was 1.2 divided by 8 whole square. So 5.1 divided by 8 minus, that is minus 1.2 divided by 8. This is the variance, 0.615. When we take the square root, that would be 0.784. So therefore, standard deviation of b would be 2 times by 0.784 times by 2, that is 1.568 or 1.57. Okay, all right. A ninth squirrel is added to the sample. Given that for all the 9 squirrels, sigma x is equal to 0. Find the body length of the 9th squirrel. Okay, so we know that for the 8 squirrels, the sum of x is adding up to minus 1.2, right? So this clearly means that if something has been added, now the sum has dropped to 0, so that means the x value of the 9th squirrel is actually 1.2. Okay, so x value of 9 is actually 1.2, which corresponds to b is equal to 2x plus 21. Minus 21 or plus 21? Yeah, 21. So that is just simply 2 times by 1.2 plus 21. So 2.4 plus 21, that is 23.4. Okay, all right. Standard deviation x for all 9 squirrels. Okay, so since we have this, when we add for the 9th squirrel, the total x squared will jump to, oh, actually, we don't need that. Okay, no, for we need of x, okay. So total new for the 9 will jump to 5.1 plus 1.2 squared. So that will be equal to 5.1 plus 1.2 squared. That jumps to 6.54. So actually, let's write this here. Okay, so the total sum has been been added to 6.54. So now total x has transformed to 0. Okay, for 9. Okay, so first we start off with the variance. Sigma x squared divided by 9 now minus sigma x over 9 whole square. So sigma x squared is now equal to 6.54 divided by 9 minus sigma x is now 0, so that's 0, divided by 9. So variance is 0.72667. So standard deviation will be square root 0.852. Right, okay. And that was C1 and 2. And 2. Okay, all right. Moving on to question number 4. So the cumulative distribution function of a discrete random variable w, which takes only the value 6, 7, 8, is given by this function, this cumulative distribution function. Okay, for w, 6, 7, 8, find EW. Okay, so to find out EW, we actually need the probability distribution table or distribution for 6, 7, 8. Okay, so to do that, we first have to, make a table for this. Okay, so let's plug in the table. So W is equal to 6, 7, 8. F of W, let's calculate the values. Wait, sorry. 6 plus 3, 9 times by 6 minus 1, 5 divided by 77. That is 45 over 77. Okay, let's keep it exact. Then we have 7. 7 plus 3 is 10 times by 7 minus 1, 6 divided by 77. 60 divided by 77. Okay, now 8 plus 3, 11 times by 7 divided by 77, that is 1. Okay, alright. Now we need the probability distribution table for this. So for the first one, it's going to remain 45 over 77. Then probability of cumulative for 7 minus that, 60 minus 45, that is just simply 15. So 15 over 77. And now the rest, that will be 1 minus 60. So that basically 77 minus 60, 70 over 77. Okay. All right. So 45. Okay. Great. That's it. So to get the EW, what we just simply have to do is multiply 6, 7, 8 with the corresponding probability values. So 6 times by 45 over 77 plus 7 times by 15 over 77 plus 8 times by 17 over 77. Okay, so first off, what you can do, 6 times by 45 plus 7 times by 15 plus 8 times by 17, then total divided by 77, that is 73 over 11, or yeah, 73 over 11. That's it. Let's leave it at that. Okay, all right. Moving on to question number 5. Okay. The weights W grams of kiwi fruit grown on a farm are normally distributed with 80 grams and standard deviation 8 grams. Okay, so W is normally distributed 80 8 squared. The table shows the classifications of kiwi fruit by their weight, where K is a positive constant. So small, large, right, okay. One kiwi fruit is selected at random from those grown on the farm. Okay. Find the probability that this fruit is large. So large is going from like all values greater than 70. Okay. So all values greater than 70. So this is what we have to do. So probability of being large, that would be, sorry, W greater than 70. So right, okay. So first off, we need to standardize it. Greater than 70 minus 80 divided by standard deviation is 8. Right. Okay. So 10 minus 10 divided by 8, that is minus 1.25. So in the standard normal table or standard normal graph, this is over here. So we are looking for the area greater than this. So this area is equivalent to probability of z less than positive 1.25. Okay, so we're going to go and look into the table for 1.25. Okay, so let's look for z 1.25, that is over here, 0.8944. So this is equal to 0.8944. That is our probability. Okay, 35% of the kiwi fruit are jumbo. Okay, find the value of k to one decimal place. So this means 0.5 plus 0.35 equals to 0.85. Now we go back to the table and see what it corresponds to. Okay, so let's find out 0.85. Okay, so 0.85 is in between these two values. Okay, so we are going to do linear interpolation to figure this out. So let's copy this and go back. Okay, so let's linear interpolate this. Alpha minus 1.03 divided by 1.04. Although the normal curve is not linear, but we can slightly assume that in a small region. So 0.85 minus 0.8485 divided by 0.8508 minus 0.8485. Okay, so we have 0.85 minus 0.8485 divided, sorry, 0. Then we have 0.8508 minus 0.8485 times by 1.04 minus 1.03 plus 1.03. So alpha is 1.0365. Okay, now to find out the actual k value, we have to do k minus 80 divided by 8 is equal to 1.0365. So therefore k is 1.0365 times by 8 plus 80. So this times by 8 plus 80, that is 88.29 or 88.3. Okay, all right. 75% of tiny kiwi fruit weigh more than y grams. Okay, weigh more than y grams. Find the value of y, giving your answer to one decimal place. Okay, so tiny are all less than 66. So basically, they're saying that we have the left tail somewhere over here. Let's call this w over here. But this y value of the area between the y value and w value in proportion of the tiny, that given that they were tiny, classified as tiny, they're 75. So between y to w, given that the fruit is less than w, that is 75. Find the value of y, giving your answer to one decimal place. Okay. Sorry, this was 66, my bad. Sorry, not w, 66. 66. Okay, all right. So let's see this. So basically they said that from y up to 66 divided by probability of w less than 66 is 0.75. So it's sort of like a conditional statement over here. So before we jump into anything, we need to convert these into values, standard values. So probability of w greater than y, no, sorry, it's going to be w less than 66 minus probability of w less than y equal to 0.75 times by probability of w less than 66. Okay, so we rearrange this into w less than y equals to probability of w less than 66 minus 0.75 of probability less than 66. So 0.25 of w less than 66. Okay, all right. So even still, there are a few steps left over here. So when we convert this into standard normal, so probability of z less than, let's call this one beta now. So z less than beta is equal to 0.25 probability of 66 minus 80 divided by 8. So 66 minus 80 divided by 8. Oh, no, sorry, no, that was 66 minus 80 divided by 8. 8. Sorry, why is it not letting me? Minus 7 over 4 minus 1.75. Okay, so how we find this area less than some negative value? 1 minus probability of z less than positive 1.75 over here. And again, we have beta also over here. This is going to be negative beta actually, because that's left of me. So over here, that will also be 1 minus probability of z less than positive beta. On both sides, we have 0.25 minus 0.25 probability of z less than 1.75. This is minus beta again. Okay. No, sorry. This turned out to be positive. Okay. So this is 1 minus that. So when we just take z less than beta, the subject, we will have 1 minus 0.25, sign change 0.25, probability of z less than 1.75. So as you can see, this cleanly just turns out to be, 0.75. This is what we have to find out first. Okay. So going back to the table, so 1.75 is this one, 9599. Okay, going back. So this becomes 0.75 plus 0.25, 0.9599. Okay, all right. So let's calculate this. 0.75 plus 0.25 times by 0.9599. So this turns out to be 0.989975. Okay, let's go back into the table again to find out the value of z that corresponds with this. So 0.98989989. This is 9893, this is 989998, and this is 0.9904. So this is somewhere in between these two values, 0.32 and 0.34. Okay, so let's copy these and take it back in our paper. Okay, so now let's perform some linear interpolation to figure out this beta over here. So beta minus 2.32 divided by 2.34 minus 2.32 equals to 0.9899975 minus 0.9898 divided by 0.9904 minus 0.9898. Okay, so answer minus 0.9898 divided by 0.9904 minus 0.9898 times by 2.34 minus 2.32 plus 2.32. So beta, positive beta, is 2.3258. We were actually looking for the negative beta, so this would be, turned to negative towards the left side of the mean. Okay, so let's go to the original value. Let's find the original value from the original variable. Thou had 80 as the mean, sigma was 8. Okay, so minus 2.35283 equals to y minus 80 divided by 8. So now let's find out the y. Y is going to be 8 times by minus 2.35283 plus 80. So 8 times by minus answer plus 80, that is 61.393. So 61.4. Okay, all right. That was the last part. Yeah, okay, all right. Moving forward. On to question number 6. Venn diagram shows the effect events A, B, C, D, where P, Q, R, and S are probabilities. A, B, C. Okay, all right. Write down the value of probability of A. Now, the probability of A is a combination of this and this, because B is part of A also. So it's going to be 0.13 plus 0.12. So 0.13 plus 0.12, that is 0.25. A given B. Now the probability of A given B is equals to 1 simply because this means that if an item is selected, if an event is selected to be B, what is the probability that it is also A? Or what is the probability that it's A? Now that's 100% certainty. How do we know the probability of A intersection B divided by a probability of B? A intersection B is 0.12 also. That's why it's 100% certainty. Or probability has 1. A given C. A and C are mutually exclusive, so that means they have no intersection. So it is equal to 0. Okay. Given that, probability of B complement intersection D complement. So B complement, let's try to fill out. B complement include this, and let's use that. And D complement is this, and this. So where the two colors are matching. Oh, I forgot about the S. Sorry. D complement also includes this. Sorry, it also includes this, and B complement also involves this. Okay. So we have this, and this. Okay. All right. And then C. Okay. So let's first write it before we forget. 0.13 plus P plus S equals to 7/10. Okay. Now the C given D. Again, it's going to be C intersection D divided by probability of D equals to 3/5. Now let's go into the diagram, see what that means. So if we erase this, C intersection D is Q and D itself is Q plus R. So Q over Q plus R. Q over Q plus R. Right. Okay. Another relation that we are going to find out is that all of these will add up to 1. So 0.25, basically 0.13, 0.12 plus P plus Q plus R plus S equals to 1. Okay, all right. So let's see how we can actually figure both P and the other things out. Okay, all right. So let's see. So from this, let's say we have this equation, second equation, and the third equation. Okay, so let's figure it out. Okay, so when we first need Q and R. Okay, they haven't exactly told us to find P, but without P we can't find out Q and R. Okay, so let's find out the P and S first. Okay, so P and S will be 0.7 minus 0.13. So 0.7 minus 0.13, that is 0.57. Now, interestingly, where does that add up is this. Okay, so from the first equation, okay, now the third equation, when we plug in the P and S, this becomes 0.25 plus 0.57 plus Q plus R equals to 1. Now this means that Q plus R is going to be equal to 1 minus 0.25 minus 0.57. So 1 minus 0.25 minus 0.57, that is 0.18. Now we have found out the Q and R, so we can use this equation to simplify this. So now the second equation, we had Q over Q plus R equals to 3/5. This transforms to Q over 0.18 equals to 3 over 5. So q becomes 3/5 of 0.18 times by 3 divided by 5, that is 0.108. Now that we have q, we can find out r from this equation. So r is going to be 0.18 minus 0.108. That actually, if you want context, that is 0.18 minus q. So 0.18 minus 0.108. That is 0.072. Right. Okay, so that's the part B. Given also that B union C complement. B union C complement. Okay, let's figure this out what this means. So B and C complement. C complement is this, 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 and indeed this. Okay, so basically all of these put together except P and Q. So 0.25 plus R plus S. 0.25 plus R plus F equals to, what did this say? 5 over 8. We need S minus 0.25 minus R was 0.072. So 5 divided by 8 minus 0.25 minus 0.072. So 0.303. Okay, all right. Let's see if there's anything else. Right, okay, right. Moving on to the next question. Okay, Adana selects one number at random from the distribution of x, which has the following probability distribution. Given that the number selected by Adana is not 5, write down the probability that it is 0. So it's basically, it's saying that probability it's either 0 or 10. And we need, given that it is 0 or 10, we need to find out that it's 0. So basically, probability, so basically what this means is probability of x equal to 0 divided by probability of x equal to 0 or x equals to 10. Okay, so basically 0.1 divided by 0.1 plus 0.7. No, wait, sorry. 1, 1, 0, sorry. So 0.1, 0.1 plus 0.7. So that's simply just 1 over 8. Okay. Show, oh no, wait, hold on. Write down the probability. It is 0. Right, okay. Show that EX squared is 75. So all of these squared times by respective probabilities. So EX squared 0 plus 5 squared times by 0.2, then plus 10 squared times by 0.7. Right, okay. So we have 35 times by 0.2 plus 100 times by 0.7, that is 75. And that's what we had to show. Okay. Find the variance of x. So the only thing missing is the expectation before we can actually do that. So 0 plus 5 times by 0.2 plus 10 times by 0.7. So 5 times by 0.2 plus 7, that is 8. So variance of x will be EX squared minus the mean square. Okay, so 75 minus 8 squared, 75 minus 64 basically, so that's 11. All right. Find variance of 4 minus 3x. Okay, this is very straightforward, very easy. Variance of 4 minus 3x equals to variance of 4 minus variance of 3x. Now, variance of a constant is 0. This one, however, becomes 3 squared variance of x. Okay, we can't have a negative variance, so we're discarding that minus over here. So, or actually, you can write it as variance of this minus this. So, minus doesn't count for variance. Remember this: the variance and standard deviation are never less than 0, or never negative. So, variance of x times by 9, that is 90. Okay, all right. Then we have Bruno and Charlie each independently select one number at random from the distribution of x. Okay, find the probability that the number Bruno selects is greater than the number Charlie selects. Okay, all right. So we can see this with a tree diagram, obviously. So wait, one after the other, or okay, all right. So we have 0, 5, and 10. 0, 5, and 10. So each of them has 0, 5, and 10, 0, 5, and 10, and 0, 5, and 10. So this is for the Charlie, this is for the Bruno. Okay. Now, all we need is just the other number to be greater than what Charlie selects. So if the Charlie has selected 0, then we only need to worry about the number 5 and 10. If Charlie has selected 5, then that means we only need to take care of 10. And if Charlie has selected 10, this doesn't count because there is no number greater than 10. So it's either this. Okay. So let's add up the probabilities. 0, 5 was the probability distribution 0 0.1, 0 0.2, and 0 0.7. Okay. So 0 0.1, 0 0.2. This is 0 0.1 times by 0 0.7. And this is 0 0.2 times by 0 0.7. Right, okay. So now 0 0.1 times by 0 0.2 plus 0 0.1 times by 0 0.7 plus 0 0.2 times by 0 0.7. That ends up to be 0 0.23. Okay, all right. Oh, that was part E. Okay. This was, wait. Oh, I already did. That was A. EX squared was B. Variance was C. And D is this. And E is this part. Okay, I don't know. Devika multiplies Bruno's number by Charlie to obtain a product. Determine the probability distribution of D. Okay, all right. So let's make a table for this. I'll make two columns for Charlie and Bruno, and then we'll get the products and probability distributions. Okay, so now let's see Charlie, Bruno, Charlie times by Bruno, and the probability over here. So Charlie can select. So the combination can be 0, 0, 0, 5, 0, 10. 5, 0, 5, 5, 5, 10, 10, 0, 10, 5, and actually I didn't know it would go that far. 10, 10. Okay, all right. So the product is 0, 0, 0, 0, 25, 50, 0, 50, and 100. Okay, now on to their probabilities. So remember, let's write it over here. The probability of 0 was 0.1, the probability of 5 was 0.2, and the probability of 10 was 0.7. Okay, so 0 times by 0, 0.1 squared. 0 times by 0.5, 0.1 times by 0.2. 0.1 times by 0.7. 0.2 times by 0.1. 0.2 whole squared. 0.2 times by 0.7. 0.7 times by 0.1. 0.7 times by 0.2. And finally 0.7 squared. Now let's calculate the values. 0.1 times by 0.1, that is 0.01. So 0.1 times by 0.2, that is 0.02. 0.07. 0.02. This is going to be 0.04. 0.14, I think. Yes. 0.07. 0.14 and 0.49. Okay, now we need another table to put the unique values of the product are 0, 50, sorry, 0, 25, 50, and 100. Okay, all right, so we just need one probability distribution table finally. Okay, so now let's plug in the values for the product. 0, 25, 50, 100. Now for the 0, let's see how many times 0 is coming. Let's use different colors for this. Okay. Okay. So 0, 0, 0, 0, 0, and that's about it. Okay, so now let's add them all up. 0.01 plus 0.02 plus 0.07 plus 0.02 plus 0.07, that is 0.19. Oh, sorry, this is the product. Let's call that D. So probability of D, that's 0.19. Okay. Now let's find out the 25. So 25 only happens once. So 25 only happens 0.04. Okay. Now 50. 50 is happening a couple of times. So 50, 0.14, 0.14. 0.28. And now 100 is only coming this. Now since this is a probability distribution table, the sum of all the probabilities of these should come out to 1. So we need to check this, okay? So 0.19 plus 0.04 plus 0.28 plus 0.49. That is 1. So that means this is a valid probability distribution table. Okay, all right. Right. Okay. So that's the end of question number 7, and that's the end of this question paper also. All right. So hopefully I'll see you in the next paper. Bye bye.